Hi everyone and welcome back. Now in today's video we are going to discuss about the data type of map in Terraform. Now at a high level overview, the map data type represents a collection of key value pair elements. Now if you have explored the list data type, so list data type consists of collection of values. However, map is quite similar but it contains the collection of key values. So let's understand this with a simple screenshot based code where you have a variable called as instance underscore tags. The type is map. Now if you see within here you have a default, and in the default you have a collection of key value pairs. So the key is name, value is app servers, key is environment, value is development, key is team, value is payments. So this is what is referred to as a collection of key value pair elements. So anytime in Terraform where you have to specify the collection of key value pairs, map is the right set of data type. Now one of the important use cases where map is used from practical point of view is associated with tags. So in AWS, tags are basically collection of key values. So here you see you have key, you have value, key value, key value. So in such cases, list cannot be used because list is basically a collection of values. So in such case, you have to use the data type of map. Now let me also quickly show you this for better clarification. So I have a simple EC2 instance that is running. Associated with this EC2 instance, there is a specific feature of tags. Now in tags, you can add multiple set of key values. So I'll say team is dev, location, let's say USA, and so on. I'll click on save. So now if you see tags, it contains multiple set of key value pairs. So this is the reason why map data type is used specifically whenever you want to create a EC2 instance with tags. Now let me also quickly show you this. So for our AWS underscore instance resource, you will see that tags here, they are defined in this specific format. In the curly braces here, you have a key and you have a value of hello world. If you look into the data type that is expected for tags, let's do one thing. Let's specify tags. Let's go a bit down. So for the tags argument here, they have clearly stated map of tags to assign in a resource. So from here you can easily identify that if you want to add tags, then you need to create a map. Now creation of map is pretty simple. In the curly braces, you have to specify the collection of key values. Let's also explore this. Now for today's practical, we have a file called as map-data-type with a very simple code where you have a variable that is defined called as myMap, and we have explicitly defined the type is equal to map, and you have a output. What this output does, whatever value the variable has, it will output that in CLI. Alright. So let's go ahead and quickly try it out. Now from the CLI, whenever we go ahead and do a Terraform apply, it is asking for a value. Now within here, if you try to add a value in terms of list, let's verify. You see immediately we got an error. So let's clear the screen. This time let's do a Terraform apply with auto approve. Again, it is asking for a value. So value we know it needs to be in curly braces, and inside the curly braces you have a key value pair that needs to be added. So let's say team is equal to payments. This time you see our apply got successfully completed, and in the output we got team is equal to payments. So this is a key value pair. Along with that, as we know that in map you can add collection of key value pairs. For example, let's say you say team is equal to payments. You can add a comma. You can say location is equal to say US. This is also working perfectly. As we can see in the output, we got location as US, team as payments. Along with that, something very similar to the screenshot. If you want, you can also add a default value as part of the map. Let's also try that out. So you can say default, and within the curly braces here, let's say name is equal to Alice and team is equal to payments. Alright, this is the default value here. Let's clear the screen. Let's do a Terraform apply with auto approve. And as expected, we did not get any error. Apply is completed, and in the output, this is the key value pair that we have added as a default value. Now, generally, whenever you explore wide set of Terraform code, you can easily identify what exactly the data type is. So here you see, you have a filter, and in the filter, you have multiple set of key value pairs. So this is the data type of map. Similar to that, you have owners, and in the owner, you have one specific ID, which is the account ID. So this is the data type of list. Again, tags is something that we have seen. This is a data type of map. So depending upon the requirement, the data type can be used accordingly. Great. So I hope with this at a high level overview, you understood the basics of the map data type, and with this we'll conclude today's video. Hey everyone and welcome back. Now in today's video we'll be discussing about one important use case which will help you not only for the exams but also for the real world scenarios. So the use case is how we can, with the help of variable, reference to one of the values that are part of the list or one of the values that are part of the map. So that is the important learning for today's video. So let's understand that. So when you do a var dot types over here, alright, so we have a variable of types and we are making this instance type as a variable. So when you do a var dot types, and in case if you need to reference to one specific value, let's say I want to reference to the value which is associated with the US West 2. So what you can do is you can go ahead and reference to the key over here. So you can say US West 2. So what will happen in such cases, that the instance type will be t2.nano. Now there's also a different way in which you can reference to the value associated with a list. However, let's quickly try with the map first, post which we'll be discussing with the list. So from the CLI, let's quickly do a Terraform plan. Now if you look into the instance type, the instance type is t2.nano, which is the one that we had referenced. Now just to verify if everything is working, let's try and change the region to AP South 1. Once done, let's go ahead and run the Terraform plan yet again. So let's go a bit up, and now you see the instance type got changed to t2.small. So I hope at a high level overview you understood that with the help of variable how we can reference to a specific key within the map. Now when it comes to list, again in this given list there are three values that are associated over here. Now if you want to reference it here, first thing that you have to change it to list so that it references to the list variable. And here since we do not have any key but the position is there, so this is basically the first position or the position 0. This is the second position or the position 1. This is the third position or position 2. So what you can do here is you can reference to the position here. So once you do that, let's quickly save this. Let's do a Terraform plan. So if you'll go a bit up, this time it would be m5.large, which is basically the position first or the position 0. Let's try the next one. Let's do a var.list with 1 on a Terraform plan. Let's go a bit up, and this time you have the m5.xlarge, which is the second one over here. So just remember this in terms of both how you can use a specific data from list as well as that of the map. So that's the high level overview. I hope this video has been informative for you, and I look forward to seeing the next video. Hey everyone and welcome back. Now in today's video we'll be discussing about the count parameter and the associated configurations. Now the count parameter on resource can simplify the configurations and let you scale resources by simply incrementing a number. So this is the high level definition. We'll be discussing more in detail about it in a moment. So let's go ahead and understand the need of count parameter with a simple example. So let's assume that you need to create two EC2 instances. Now one of the common approach here is to define two separate resource block for AWS underscore instance. So you will see that you have one block for instance 1 and second block for the instance 2. So if you do a Terraform plan, it will go ahead and it will create two different EC2 instances. So before we proceed further, let's quickly look into it. Now let's go ahead and understand it. So if you look into this configuration file, we have the provider and we have two separate resource block which creates two different EC2 instances. So this is the first resource block and the name is instance 1, and you have a second resource block and the name is instance 2. So if you do a Terraform plan, it will go ahead and show you the plan for two different resources that needs to be created. So tomorrow, if you want to create three EC2 instances together, whenever you do a Terraform apply, what many of the users they do, they just copy paste this, they just rename it to instance 3 and so on. So when you do a Terraform plan on this specific configuration, so here within the plan you will see that there are three resources that needs to be added. So you have the instance 3, you have the instance 2, and on top you have the instance 1. So this is the simplistic approach in which you copy the resource block multiple times if you need multiple resources to be created. However, this can be a bit of a pain. So let's say you need 10 EC2 instance, so you'll have to copy paste this 10 times. So that is a bit of a pain and even your code will become quite long. So what you can do instead is you can make use of the count parameter. Now with the count parameter, you can simply specify the count value and the resources can be scaled accordingly. So all you have to do here is you have to specify count is equal to 5 or maybe count is equal to 20. So then what will happen is 20 EC2 instance will be created. So this is a much more better approach. So let's try this out. Now from the configuration file, let's go ahead and remove the other resources. Let's go ahead and add a count parameter and let's say we'll say count parameter as 3. Let's go ahead and save this. Now let's clear the screen and let's do a Terraform plan. Now as expected, now you can see that there are three resources to add. Now you have the instance, you again have one more instance, and you have one more instance. Now do remember that here it starts with 0. So 0 is the first, 1 is the second, and 2 is the third. So this is one important part to remember. Great. So I hope at a high level overview you understood the importance of count parameter. The next important aspect here is the count index. Now in the resource block where count is set, an additional count object is available in expression, so you can modify the configuration of each instance. So this object has one attribute as we were discussing, that is count.index. So the distinct index number which is starting from 0 corresponds to the instance over here. So again, this might be a little confusing if you just look into the definition. Let's look into it with a practical use case so that it becomes better understood. So let's understand the challenge by just using the count parameter. Now in the below code, Terraform will create 5 IAM users, but the problem is that all will have the same name. So this is the IAM user, the name is load balancer. If you do a count, what will happen is all of the IAM users will have the same name as load balancer. And for the resources where you cannot have the same name, the apply will fail. So by just using the count parameter, it does not really become the best of the approach, specifically whenever you want some kind of a loop or iteration. So let's look into it practically. So if you see that we have a IAM user, the name is load balancer, the count is 5. So let's go ahead and see what happens when you do a Terraform plan. So let's do a Terraform plan here. So currently here you will see that you have 5 different IAM users that would be created. Again, you see it starts with 0. So you have 0, 1, 2, 3, 4. So in total it is the 5 different resources. Now ideally what you want is that each of the resource should have a different name, because the same name either might not work all the time, and in certain situations it is not expected. So let's say that you are planning to create 5 new EC2 instances and all of the EC2 instance has the same name. So then it becomes difficult for you to identify the EC2 instance from the console since everyone has the same name. So what you want is you want 5 different EC2 instances to have 5 different names so that the identification is simpler. So in order to overcome this specific scenario, you can make use of count index. So now what will happen is the count index allows us to fetch the index of each iteration in the loop. So currently there are 5 count and you have load balancer dot count dot index. So now what will happen is it will go through each iteration and the count dot index will be changed accordingly. So it would be load balancer dot 0, load balancer dot 1, load balancer dot 2 and so on. So let's try this out. So within here you can specify the count dot index over here. Alright, let's go ahead and do a save. Let's do a Terraform plan yet again. And now if you look into the name, you have load balancer 4 associated with the 4. You have load balancer 3, load balancer 2, load balancer 1 and load balancer dot 0. So this will effectively create 5 different IAM users which will have a different name altogether. So I hope at a high level overview you got the importance of count dot index. So generally whenever you do a count, what will happen is it acts as a loop. So this resource will run 5 times. So similarly, each time the resource is run in a loop, this count dot index will be incremented. So first time it will have a value of 0. So whenever this runs first time, it will be load balancer dot 0. Then second time it will run, it will be load balancer dot 1 and so on. So that is the importance of count dot index. So now let's move one step further and understand the challenge whenever you are making use of a default count dot index. So having a username like load balancer 0, load balancer 1 might not always be suitable. It becomes really difficult to understand what is the purpose of load balancer 0, load balancer 1 and so on. So better names like dev-load balancer or stage-load balancer or prod-load balancer is much more better. And from the name itself you can identify that this dev-load balancer might be used for the dev environment, prod-load balancer might be used for the production environment and so on. So you need a naming convention similar to this. However, you still need the count dot index so that it can quickly iterate through it. So what you can do is you can make use of a variable. So let's say you have a variable of ELB underscore name where you specify a list. So you have dev load balancer, stage load balancer, prod load balancer. And then what you can do is you can do a count dot index on this specific variable. So on the first iteration, the count dot index will have a value of dev load balancer. On the second iteration, it will have a value of stage. On the third, it will have a value of prod and so on. So this is a really great aspect and this is something that is much more better than just doing a plain iteration based on count. So let's look into it in practical way as well. So let's go ahead and create a new variable. The variable name, let's call it as ELB names, and the type that we'll be specifying would be list, and let's specify a default values here. First we'll call it as dev load balancer. Second would be stage load balancer, and third would be the prod load balancer. Alright, so we have the variable that is defined. So now what we want is we do not want count.index to iterate through the number and use the number which was part of the count. We want to iterate it through the values that we have as part of the variable of ELB underscore names. So now what you can do is first is you can specify var.elb underscore names. This is something that we already know. So var.elb underscore names will fetch the value from elb underscore names. However, we can also make use of count.index. So let's try it out. So I'll say count.index over here. Let's do a save. Now the only change that you have to do is you have to change the count. Since we only have 3 names over here, you can change the count to 3. Let's do a save yet again. So from the CLI, let's do a Terraform plan. So now if you look into the name, for the third one you have prod load balancer, for the second one you have stage, and for the first one you have the dev load balancer. So let's go ahead and also do a Terraform apply so that we are sure that everything is working as expected. Let's do a yes. Great, so our resources are created, and confirming it from the CLI, you should see that there are 3 IAM users called as dev, stage and prod load balancers that have been created. So that's the high level overview about both the count parameter. We also looked into the importance of count.index, both by referring to the value of count as well as by referring to the value as part of the variable list. So with this, we'll conclude today's video. I hope this video has been informative for you, and I look forward to seeing you in the next video. Hey everyone, and welcome back. Now in today's video we'll be discussing about the conditional expression. Now the condition expression uses the value of a boolean expression to select one of the two values. So if you look into the syntax of a conditional expression, you have your condition and you have true value and you have a false value. So if this condition matches, then this is the value that will be used. If it does not match, then the false value is something that will be used. So let's go ahead and understand the need of conditional expression with a simple example. So let's assume that there are 2 resource blocks as part of a Terraform configuration file. So this is a Terraform configuration file and you have 2 resource block which creates a EC2 instance. Now what you want is that depending upon the variable value, one of the resource block will run. So let's say that there is a variable called as isTest. So isTest basically means, is this environment that you are planning to create with Terraform, is it going to be used for testing purpose or is it going to be used for the production purpose? Now, if it is going to be used for the testing purpose, then what will happen is the dev related configuration will be executed. If the variable associated with the isTest is false, that basically means that the environment that needs to be created is not a testing environment, then what will happen is Terraform will run the resource associated with the production block. So this specific approach can be solved with the help of conditional expression. So let's jump into practical session so that this can be better understood. So for today's demo, we have a file called as conditional.tf, and in this file there are 2 resource blocks that are available. One is for dev and the second resource block is for prod. Now this is very similar, where within a Terraform configuration file you have 1 resource block for dev, 1 resource block for prod. Now when you do a Terraform plan over here, what will happen is the Terraform will create both the dev as well as the prod related resource. So let me quickly show you this. So when you do a Terraform plan, there will be 2 resources that will be created. So now if you go a bit up, you will see that you have the prod instance. So the prod instance has a t2.large. So this is a bigger instance, and you have one more instance which should be dev, which is t2.micro. So I hope you understood this basic approach. Now what we want is that we want the developer to specify if they want a dev or a prod instance. If they want to create a dev instance, they should be able to do that. If they want to create prod instance, they should be able to do that from this same configuration file. So in order to achieve that, what you have to do is you have to create a variable. Let's create a variable called as isTest. Alright, so this is the variable. Now similar to the diagram, if the isTest is true, that means the environment that the developer is trying to create is a test environment, then automatically the dev resource block will be executed. If the value associated with the isTest variable is false, then the prod resource block will be executed. So what we have to do is we have to add a specific condition in each of this resource block. So let's try it out. So what we can do is we can add a count parameter and we'll say var isTest is equal to true. So if the var isTest is true, then the value associated with the count is 1. else the value associated with the count is 0. So this would make better sense if you have gone through our count video. So what will happen is, if the value associated with isTest is true, then the count will be 1. That basically means that one EC2 instance will be created with the configuration that is being specified over here. If the value is false, then the count will have 0. That means no EC2 instance will be created from this specific block. Now in a similar way, let's also define a count here. So I'll say var isTest is equal to false, and if it is false, then we want a count value to be 1, so that one EC2 instance will be created from this prod resource block. And if it is true, then we do not want any EC2 instance to be created. So let's do one thing. Let's try it out. Now, before you can try it out, you have to assign a value associated with the specific variable. So I see that there is a typo here. Let's fix it. So now let's create a new file. I'll say terraform.tfvars. This time we'll give a value of true. So now we know that if a value of true is given, then this specific resource block will have the count of 1. So t2.micro will be created. So let's try it out. Let's do a Terraform plan. And ideally here you should see the t2.micro resource that is created. Now you can also change this number to 3. So now what will happen is that if the value associated with isTest variable is true, then the count will be 3. So this in turn is something like when you explicitly define count as 3. So this is what exactly it is. So let's try it out. So I'll clear the screen. Let's do a Terraform plan yet again. So now you see that you have 3 resources, and all of the resources are based on the t2.micro instance type. Great. So depending upon the value here, so this value basically fulfills this specific expression. Now let's give a value of false. So when you do a value of false, what will happen is that this specific expression does not hold to be true, and this is the reason why the count of 0 will be used. That basically means that this EC2 instance will not be created. However, on the other side, since we have given the value associated with the isTest as false, then the first condition will be used, which is basically the true value. So let's try it out. So when you do a Terraform plan, this time you should see an instance type of t2.large that would be created. So if you go a bit down, you see this time you have a t2.large based instance type that is being created. Great. So whenever you are writing the conditional expression, just remember that the first part here, this first part is the condition. So in this case, this is the first part. Then you have a question mark. Then you have the true value. So you see you have a question mark, you have a true value. So true value is 3 in this case, and then you have a false value. False value is 0. So I hope you understood this basic syntax of the conditional expression. So with this we'll conclude today's video. I hope this video has been informative for you, and I look forward to seeing you in the next video. Hey everyone, and welcome back. Now in today's video we'll be discussing about the local values in Terraform. Now a local value assigns a name to an expression, allowing it to be used multiple times within a module without repeating it. So there are multiple use cases of local values. Let's discuss one of the simplest one, where what we are doing is within the locals we have a common underscore tag, and we are defining two key value pair here. One is the owner is equal to DevOps team, service is equal to backend. So this is what we are defining within the locals. Now within two AWS resources, one is AWS underscore instance and second is AWS underscore EBS underscore volume, and both of them supports tags. So within the tags we are doing local dot common underscore tags, that is local dot common underscore tags. So now what will happen is any resource that gets created, these resource will inherit both these key value pair as part of the tags over here. Now, if you're not using that, then one of the primary ways is you have to add both the owner as well as the service within the tag of each of the resource that you create. So this is one of the simplest way in which you can achieve that. So let's quickly look into it so that it can be better understood. So currently I have a file called as local-values.tf and I have defined the configurations here. Now if you'll see here, within the first section you have the local. Within here you have common underscore tags where we have defined two key value pairs. One is the owner DevOps team, the service as backend. Now within the three resources that we have over here, within the tags we have specified local.common underscore tags. So this EC2 instance that will get created will have these two tags. Same goes with the second EC2 instance. Again, the second will also have these two tags. And the same goes with the third EBS volume. The third EBS volume will also inherit the tag. So you can define it only one time and it can be used in multiple places. So let's go ahead and do a Terraform plan to understand how it might work. Now, if you go a bit up, you will see that there are total 3 resources that needs to be added. First resource, you will see the tag as owner and service. So this is the EC2 instance here. The second EC2 instance, again it has the same tag. And the third EC2 instance, again it has the same tag over here. So this is one of the ways in which you can use the local values for multiple resources. Now, apart from those static values, one of the great benefits of local values is that it supports multiple use cases that can include condition expressions, it includes functions and so on. So if you see over here within locals, we have a name underscore prefix and now we basically have the conditional expression over here. So now if you have to refer this condition expression in multiple resources, instead of hard coding this entire expression in multiple resources, you can put it in local and then from the resource you can just say local.name underscore prefix. Now in a similar way, if I have to show you from the documentation, within the documentation you see under the locals they have the instance ID and you have basically the concat function and this is basically the arguments over here. So the entire function and the associated arguments are within the local. So from the resource, if you have to use this function and the arguments, let's say there are 5 resources where you have to use this same function and the associated arguments. So instead of copy pasting this function in 5 resources, you put this entire function in locals and from the resource just refer to local.instance underscore IDs and that's about it. Alright, so I hope at a high level overview you understood the importance of local values. So let's look into some of the important pointers for local values. First one is that local values can be helpful to avoid repeating the same values or expression multiple times within the configuration. This is something that we have already seen. Second important pointer is that if local values are overused, they can make a configuration hard to read by a future maintainer by hiding the actual values that are being used. So you should use local values only in moderation in situation where a single value or result is used in multiple places and that value is likely to be changed within the future. So that's the high level overview about the local values. I hope this video has been informative for you and I look forward to see you in the next video. Hey everyone and welcome back. Now in today's video we'll be discussing about the Terraform functions. So the Terraform language includes a number of built-in functions that you can use to transform and combine values. Now the general syntax for the function call is a function name followed by comma separated arguments in parentheses. So if you see here you have a function, so this would basically be the function name followed by multiple arguments that are supported as part of the function. So if you look into the example here, you have a max which is 5, 12 and 9. So max is basically the name of the function, 5, 12 and 9 are basically the arguments. And the output of the function is 12 which is basically the maximum of all of these 3 numbers. So this is one sample function that is available in Terraform. Now the Terraform language does not support user-defined functions, and so only the function built into the language are available for use. So there are multiple categories that are available for functions, like you have numeric, string, collection, encoding, file system. You even have date and time, hash, crypto, IP, network, and type conversion. So these are the high level categories, and within the categories there are multiple sub-functions that are available. So let's quickly look into it, post which we'll be discussing in more detail. Now if you look into the Terraform page of built-in function over here, this is the page over here. On the left hand side you have the high level categories here. So you have numeric, string, collection, and so on. Now if you expand this, you have multiple functions, like within numeric you have max, you have min, and so on. Within the string you have format, lower, join, and so on. So each high level category has multiple functions that can be used. So one of the ways in which you can test this function is with the help of Terraform console command. So let's look into it. So currently I am in the CLI. So let's do a Terraform console command, and now you got a prompt. So here you can go ahead and try out various functions to see how exactly they work. So let's say you do a max on 10, 20, 30, and the output you see 30. In a similar way, when you do a min on 10, 20, 30, the output you get it as a 10. So the functions that you want to try it out, you can do it within the Terraform console command. If things are working as expected, then you can add it as part of your Terraform configuration. Now one of the good things within the documentation is that for each function they have given an example. So for an example of max function, so within max function you have various examples that are available. So let's open up few more. So let's say split. So again, for split you have the basic syntax, and they have given you the example, and they have also shown you the output on what exactly the split function will do for you. So this is really great in understanding what a function does at a high level overview. So let's do one thing. Generally when you do it in this way, it will not really give you good amount of knowledge as far as the practical experience is concerned. So what we'll do, I already have a ready-made Terraform configuration file that I have created, and that file has been using multiple functions. So we'll use that file to understand on how functions are used in real world environment. So for today's video, I have a file called as functions.tf, and this is a simple file. All it does is it creates a EC2 instance and it creates a key pair to login. So these are the only two resources that it is been creating. Now within this we have made use of multiple functions so that it allows us to understand on how exactly it works. Apart from that, we have also defined functions at different locations. So within locals we have a function of format date, we have timestamp function, then you have a map also available, then you have a function of file, you have a function of lookup as well, and if you go a bit down you also have a function of element. So few functions are being used. Let's go ahead and understand this. Now we'll start with our resource of AWS_instance. This is something that we have been using extensively within the course, so I hope you know what this resource does. Now if you look over here, let's start with the first one over here where we are defining the AMI. So within the AMI we are making use of a lookup function where you have the var.ami and var.region. So first let's look into var.region over here. So if you look into the variable of region, the default region here is AP South 1, which is Mumbai, and this lookup is also making use of one more variable which is var.ami. So var.ami is nothing but map. So what this map does, it basically links a region to the associated AMI ID. So US East 1 has a specific AMI ID, US West 2 has a specific AMI ID, and AP South 1 has a specific AMI ID. So I hope you understood what var.ami is, what var.region is. Now the question that comes is, what exactly is a lookup function? So coming back to the documentation, let's go to collections and you should see a lookup function that is available. So let's look into it at a high level overview. So what lookup does, it basically retrieves the value of a single element from a map given its key. So this can be better understood with this syntax. So you have a lookup, you provide a map, you provide the key, and you also have the default value that will be returned if it does not match the one in map. So within the example, it can be better understood. So basically you have a map like A is equal to AY, B is equal to BEE. Then you provide the key. So the key is A and the default value is what? So what will happen is that the lookup function will return the value associated with A. So in this case, the value associated with A is AY, and that is the reason why you are able to see AY within the output. Now in the second example, you are trying to look up the key of C, which is not present at all within this given map. So now what will happen is you also have a default value. So if you see, this is the default value. So if things are not part of the map, then you will get the default value within the output. So this is what the lookup does. So let's try it out once. So I'll copy this up. Now within the console, if you run this command, you should get the expected output, which is AY. Now if you replace the key with B, then you should see BEE as the output over here. And in a similar way, if you replace the key with certain non-existent key like Z, then it will give you the default one, which is what. Now if you look into our lookup function here, first part is the var.ami. So var.ami is nothing but this map that is being provided. So if you see, this is nothing but the map over here. Then you have the var.region, and var.region, as we have seen, it is AP South 1. So now what it will do is it will look into the AP South 1 inside this map, and then it will return you the associated AMI ID over here. So that is exactly what this lookup does. So final result of this AMI would be the AMI ID that is being associated with the AP South 1 region. Great. So that is what the AMI lookup function does. So I hope you are starting to get a gist on how beneficial functions can be. Great. So that is the first lookup function that we are using. Now the second thing is count. We have already seen what count does. So basically this will create two EC2 instances. Now within tags, you are making use of an element function over here, and you are making use of var.tags followed by count.index. Now count.index is something that we have already seen earlier. So let's look into what var.tags does. So if you go a bit up, you have a variable of tags. The type is list, and default there are two tags that are available. One is the first EC2 and the other one is second EC2. So these are the two tags that are available. So you have the first EC2, second EC2 followed by the count.index, and then you have the element function. So in order to understand this properly, we need to look into what exactly the element function is. So in the documentation, let's go to the element function. So if you'll see, element retrieves a single element from a list. So the syntax is element, then you provide a list, and then you provide the index over here. So within the element, you see in the list there are three items. You have A, B and C, and then you provide the index. So index here is 1. That's why you are seeing B. So let's try it out. So I'll copy this up and let's paste it. So here the element that will be returned is B. Now remember that everything starts with 0. So this is the 0, this is the 1, and this is the 2. So when you press enter, you get B. When you do 0, you get A, and when you do 2, you get C. So all element does is that depending upon the index that you provide, which is 0, 1 or 2, it will retrieve one of the items that is part of the list. So now you can better understand it. Since we have count of 1, first time what will happen is that the count.index will be 0. So second time the count of index will be 1. So when the count of index is 0, the element that will be returned would be first EC2. Then the second time the count of index will be 1, and then the second EC2 tag will be returned. So now what will happen is that the name of the EC2 instance here, first name will be first EC2, and the second EC2 instance that will be launched, the name of that would be second EC2. So that is what the element does. Now we'll be doing this practically in terms of Terraform apply so that it becomes better understood. But first just understand this at a high level overview, post which we'll be discussing in detail. Now in fact, let me do one thing. Let's do a Terraform plan so that this becomes better understood. So from the CLI, let's do a Terraform plan. So within the Terraform plan, what will happen is that the value associated with the functions, you would be able to see that. So we know that this will go ahead and create two EC2 instances. So let's start from the top. So this is the first EC2 instance that is being created. As expected, you see the AMI, which is 476, which we got it from the lookup table, is associated with the AP South one, primarily because within the lookup we had specified the var.region which had the value of AP South 1. Now if you change the value of AP South 1 to US East 1, then this specific AMI would be returned. So that is the first part. Second part is this element over here. Let's look into the tags. So if you look into the tag, the first EC2 instance has a tag of first EC2, and let's go a bit down. The second EC2 instance has a tag of second EC2 over here. Alright, so I hope you understood what element function does and what is the role of count.index. Now again, if you're a little confused with count.index, just go through our count video where we discuss about it in more detail. The next function that we make use is the file function over here. So let's minimize this, and within the file system you will see that there is a function called as file, and the syntax is file followed by the path. All it does is that it reads the content of the file at a given path and returns them as a string. So if you'll see, you have a file, then you have a path.module, which is basically the specific path, followed by hello.txt. So what it will do, it will return the contents that are part of hello.txt in a string over here. So that is what it does. So let's try it out. So within here, what I have done is we have a file, everything remains to be the same. The only change is id_rsa.pub. So that basically means that the EC2 instance that gets created, that will be created using this specific key pair. So let's clear the screen. Let's do a Terraform console. And now when you press enter, you see that you get the contents that are part of the id_rsa.pub file. Now this file is within the same directory where our function.tf is present. So if you look into this directory of functions, we have both the functions.tf and id_rsa.pub, and all the file function has done, it has basically extracted the content of this file and presented to you as a string. Great. So I hope you understood what file function does. Now, if you go a bit down, you also have an output of timestamp, and it is basically referencing to local.time. Now, if you go a bit up within locals, in fact, we have two functions that are being used. One is the format date and second is the timestamp. So these are the two functions which are being used. Now, if you go back to the documentation, if you will see the timestamp, what timestamp does, it basically shows you the current timestamp. However, the current timestamp is not easy to understand over here. So what we make use to better format it is format date function. So within the format date function, what we do, we have a spec. So there are multiple spec that are available. So you have DD, MM, YY and so on. So DD, MM, YY is something that is quite easy to understand. So we use this specific format here. So if you see, we use the DD, MM, YY over here. Then you have a comma. You see, you have a comma and same over here. And then you have to specify the timestamp. So the timestamp is something that we are retrieving from the timestamp function. So if you go to the timestamp over here, this is the timestamp, and on top of this we make use of format so that we see this in a better detail. So that's what the format and timestamp function does. Great. So these are the high level overview about this specific terraform.tf file. Now if you'll see within the output, what we are doing within the value, we have a local.time, which is nothing but the local.time. So any value that is being returned from this function will be outputted after the Terraform apply. So that's the overview. Let's go ahead and run this. So let's do a Terraform apply. And let's put a yes. Now if you see within the EC2 key pair, you are seeing the exact key pair, which is basically the output of the file function that it computed. So let's do a yes. Great. So in total 3 resource has been created. Now if you look into the output, you have the output of timestamp and it states the date, which is 24th April 2020, 1410 UTC. So this is why we are actually making use of format date. Otherwise the output of timestamp is little difficult to read. Now from the EC2 console, you will see that there are 2 EC2 instances that have been created. The first has a name of first EC2, second has a name of second EC2. Essentially what is happening is that you have a tag which has a name of first EC2 and second tag which has a name of second EC2. Great. So I hope at a high level overview you understood what Terraform functions are. We looked into it both by manually running them in the Terraform console and also doing it practically to see on how helpful Terraform functions are whenever you're writing the Terraform code. Now do remember that there are a lot of functions that are available. Now it is not really feasible to cover each one of these functions in detail. However, once you understand the concept of functions and how we can use it within the Terraform configuration file, then it is much more easier to go ahead and understand about the other ones that might be useful within the Terraform code. Now one thing that I will really encourage you is to practice this thoroughly, understand this video thoroughly, so you should be able to understand each of the functions that have been used and the exact use case. So that's the high level overview about the Terraform functions. I hope this video has been informative for you and I look forward to seeing you in the next video. Hi everyone and welcome back. Now in today's video we are going to discuss about data sources. Now one thing that needs to be remembered, again this is a very important topic, and whenever you are exploring the production level code, you will see that data sources is being used quite extensively. It allows you to make your code much more flexible and modular. So with this base set, let's go ahead and understand the basics of data sources. Now at a very high level overview, data sources allows Terraform to use or fetch information that is defined outside of Terraform. Now this is a very big advantage and it can solve much more complex cases in an easier way. So let's understand this with an example where let's assume you have a Terraform code and let's also assume that you are using a AWS as your provider. Now in a typical approach where data sources are being used, what happens is you define a data source block in your code. Now this data source block, as we were discussing, it allows Terraform to fetch information that is defined outside of Terraform. So this information can be in AWS, this information can be some text file that is located in your workstation and so on. So in such case, data source block, depending upon what logic is being used, it can go ahead and it can fetch the information from a specific provider. For today's example is what we are considering. So here, depending upon the data source block that is being used, here what is the logic? It is fetching the details of EC2 instances in the region. So whatever servers that are running in a specific region in AWS, it will fetch that information. And after fetching that information, it will pass on that information to the resource block. And whatever logic that the resource block has, it will use it accordingly. So this part of fetching the information outside of Terraform is what the data source block allows us to do. So what we are going to do in today's video, we'll take up 3 examples related to data source that allows us to understand what kind of information it can fetch. And once we understand the basics, then we'll go in much more detail in the upcoming videos. Now the example number 1 that we are going to explore is related to reading the information about the DigitalOcean account. Now just for simplicity, I have taken an example of one more provider apart from AWS so that things are much more easy to understand considering that Terraform has so many providers. So in here we are using a data source block that allows us to fetch the information about the DigitalOcean account that we are using. Now if you look into the screenshot, it is very simple. It is just a single liner block. What it states, data followed by what information that we need. In such case, it is DigitalOcean account and this is the local name. Now for today's video, I have a file called as data-source-01.tf. This is specifically related to the DigitalOcean example that we are discussing. Now again, if you do not have a DigitalOcean account, that is completely fine. The aim of today's video is to understand the data source concept at a high level overview. Apart from that, there are 2 more examples that we are going to take which you will be able to implement. So let's look into what exactly this file does. So you have a provider of DigitalOcean and here I have added a token so that Terraform can connect to our account. Apart from that, I also have a simple Terraform required providers block, primarily because DigitalOcean is not one of the official providers. Anyways, coming back to the most important part, which is this data block. So what does this do? You have a data DigitalOcean underscore account followed by the name. So this name can be any random name that you can give. However, the most important part is that this specific line, a single line, can go ahead and read some important information about your DigitalOcean account. Now again, one thing to note is that we are going to discuss about the data sources in much more detail in the upcoming video. At this stage, just to make sure that we understand the concept at a high level overview, we are directly starting with few examples so that practically things becomes much more clear for us. So as we are discussing today, we are going to use this specific block of data DigitalOcean underscore account followed by the name. What it does, it fetches the information of the DigitalOcean account. Very simple thing to understand. Now from the CLI, let's quickly do a Terraform init so that it downloads the required provider plugins. And once this is done, we can do a Terraform apply with auto approve. Now one thing that you will see is that whenever you are using a data block here, you see it states reading and after that it states read complete after 1 second. Now if you'll explore the slide that we were discussing, it states that data source allows you to use fetch information defined outside of Terraform. So this part of fetching information outside of Terraform is what we are referring to here as reading. Alright, so it's reading information or fetching information and so on. Now second part that needs to be understood is that data source by itself, it will not create resource for you. The main aim is to fetch some information from the provider depending upon the requirement. And this is the reason why the apply is completed, but you see there are no resources that are created. It has just fetched the information. Now the question that comes is where exactly it has fetched the information, because in the CLI there are no information that is shown. So in such case, you see a terraform.tf state file is created and inside this tf state file, all the information that it has fetched is being stored. For example, the DigitalOcean account, basically if you see the token, we have added a token associated with a provider. So this is the token that Terraform has used to fetch the information about the account. Now what information it has fetched? You can see over here. It has fetched what are the limits about the number of servers that can be launched. What is the email ID associated with the account? So in this case, email ID is instructors@kplabs.in. Is the email verified? Answer is true. Floating IP limit, status, and so on. And in fact, same you can see from the documentation itself, which states that this specific data source block allows you to fetch these information like how many servers can be launched, what is the email is verified or not, the status, and so on. Alright, so I hope with this you understood the example number 1, which uses the data source block to fetch the information about the DigitalOcean account. Now comes the example number 2, which every one of us can practice. This is a simple example which allows you to read a file. So again, we are using a data block here of local underscore file, and here we have to specify a file name, and in this case the file name is demo.txt here. So what this will do, whatever contents that are part of this demo.txt file, this data source block will go ahead and read it. That is the only thing that it will do. Let's go ahead and try this out. So let's do one thing. The earlier code that we had, just for simplicity, I'll just name it .back so that this does not come into picture when we do a Terraform plan or Terraform apply. Let's create one more file. I'll say data-source-02.tf, and similar to the example that we had seen within the code, I'll just add the contents. Again, all of these are part of the GitHub page so that you can reference to it. Now, if you look into this specific data source of local underscore file, the description is very simple. It states read a file from the local file system. Alright, so let's understand this. You have a data, local file, a random name over here. The file name you have to specify here. In this case, it is demo.txt. So you need to have a file called as demo.txt. And from here, I'll say hello world, I am learning data sources. Alright, I'll save this change. Now from the CLI, let's clear the screen. Let's quickly do a Terraform init to ensure that we have the right set of provider plugins, specifically the local one. Once done, you can do Terraform apply auto approve. Very similar, since the data block is being used, it is reading the information based on the specific resource block. And as we know, where does it store the information? It stores the information in the terraform.tfstate file. So if you see in the tfstate file under the local underscore file, the content here you see, it states hello world, I am learning data sources. Alright, so I hope with this you have started to understand what data sources allows us to do, which is to read or fetch information that is defined outside of Terraform. Now, data source block by itself does not do much. It reads the information for you, and then you can pass the data source block, whatever information that is being fetched by the data source, you can pass it to the resource block to be able to do something. There are a lot of use cases, we'll be discussing it at the appropriate time. However, in case if you would like, you can also do something like output, say data, and in the value, you can say something like data.local underscore file.foo, and then you can just look into the attributes where exactly it is storing the contents. It is storing in .content. So you can say .content. Alright, I'll save this. So now what it will do, whatever data that this block has read, it will output it to the CLI. So let's do a Terraform apply again. And now you see whatever data the data source block has read, we are getting it in the output as part of our CLI. Now before we proceed with the example number 3, there is one part in the code that can lead to a little confusion, which is path.module. We know demo.txt was the file that we had created, but this path.module is not clearly understood. So at a high level overview, path.module, it returns the current file system path where your code is located. For example, this specific file demo.txt, it is in C drive, users, ZealV, KPLabs, Terraform and so on. So do you want to mention the entire path? So if you see the path looks like C drive, users, ZealV, KPLabs, Terraform, sometimes the paths are much more bigger. So instead of mentioning the entire path, you can also use path.module, which will redirect Terraform to the current working directory from which the expression is being loaded from. Alright, since we have added the code in this path under the data-source-02.tf, it will automatically compute this path for you. Alright, so this is what the path.module allows us to do. Again, there are a lot of flexibility here, but in a simplistic point of view, it returns the current directory or a current folder where your code is located. Now the example number 3 allows us to fetch the EC2 instance details that are running in your AWS account on a specific region. So again, you see the code block remains to be very simple. Data AWS underscore instances followed by any random name that you have given here. So let's try this out as well. So the 02 file, I'll just rename it. I'll just call it as BAK so that it does not run when we do a Terraform apply. So let's go to the example number 3. The file name, I'll call it as data source 02 or 03.tf. Now within here, I'll say data AWS underscore instances. You can just give a local name here, and that's about it. Now one thing that needs to be remembered here is that AWS has multiple regions. You see there's so many regions. Now for which region you want to fetch the instance details is something that needs to be taken a note of. So just for simplicity, I'll say provider of AWS, and let's say region that I want to read the data from is US East 1, which is North Virginia. Alright, so this North Virginia, you see the code is US East 1. I'll save the change. Now from the CLI, let's quickly do a Terraform minute. Let's ensure that the AWS provider plugin gets installed. So currently it is installing the AWS plugins. Once this is done, let's go ahead and do a Terraform apply with auto approve. Let's see whether this works or it does not work. So the read is completed. Now if you look into the terraform.tf state file associated with our data source of AWS underscore instances, there is no details. You see ID, instance tags, everything is empty. Now the reason why it is empty is because there are no instances that are running in the region. So just for simplicity, let me just launch 2 instances. I'll say test instances, number is 2. I'll quickly go ahead and launch the instance here. Alright, let's go to instance. Let's refresh. We have 2 instances. Let's call first one as 01 and second one I'll just call it as 02. So if you see, there are 2 instances here. The instance state is pending. Let's quickly wait for a minute for the instance state to be running. Great, now the instance state is running. So now let's clear the screen again. Let's go ahead and run the Terraform apply. Alright, as expected, it has read the information and there are no resources that are created. Now if you look into the Terraform TF state file, you see this time it is showing you 2 instance IDs. One is A31, second is 997. You can always verify, you see. First one is A31, second one is 997. Then it is also showing you the private IP addresses associated with the instance, the public IP address associated with the instance, and few other details. Alright, so I hope with this you also understood how the data source block of AWS underscore instances allows you to fetch some information about the EC2 instances in a specific region. Now, before we conclude, one thing that I wanted to share is that at this moment, we just learned on how we can use the data source block to fetch some information that is defined outside of Terraform. So we have explored multiple examples related to the provider of cloud like DigitalOcean or AWS. We also looked into the provider of local file where information of a text file is being retrieved. Now, after the information is retrieved, the other blocks like the output block or even the resource block can fetch this information and it can be used to create or modify some resources in your infrastructure accordingly. For example, after this information like private IP has been fetched, you want to go ahead and perform some logic on the instances. So this kind of an approach where the information of data block is passed on to the resource block for creation of instances or management of instances are something that we'll be discussing at a later stage of this course. But at this stage, the overview of the data sources and how it can be used to fetch the information is something that needs to be understood, and that was the aim of today's video. So I hope with this you understood the basics, and with this we'll conclude today's video. Hi everyone and